stop the recording if you want. Just when if there is anything you want to what I can say, just pause the recording, not to stop the recording, okay? Because we will have the one recording only in the for the full session. Hi everyone. Who knows me? I am Nagendra Singh, founder of Harita Hive and Matrix here. We are launching this webinar today, which is for the soil erosion modeling. So we have the instructor Nihar. He has worked on the visual modeling earlier also, and he is going to take uh, the session for next 5 days. The session would be from 7:30 to 9:30. If there is anything we need to extend, like if so, we can extend till 10 o'clock. Not an issue in that. Nihar, uh, just start the session now.
Okay. So we can start now, or we can wait for another 5 minutes so that other members
Yeah,
can join.
we can wait for another 5 minutes.
Okay.
So for this session, we have more than 55 registrations. So I'm hoping that 30% of like 30 people out of them will join the webinar today. I have got messages from 5 people that they are going to join by 7:50 or 7:45. So not an issue that those five will join later. Other than that, let's wait for 5 minutes and then we will start. If anyone has any question, they can ask right now. Any general question related to your career, related to anything you want to ask about geospatial technology, GIS, remote sensing, or anything, you can ask right now. And then we will start the session.
Hello?
Yes, Abdul,
Hello?
please tell me.
Yes, sir. Sir, is this webinar is a series of webinar or this is just one webinar regarding this GIS and
And
remote topics?
uh, Abdul, what we do is we actually offer webinars, particularly on the different topics. And our webinar are particularly either for 3 days, 5 days, or either for 1 month. So earlier we have offered the webinar on air quality monitoring and mapping, role of GIS and remote sensing into air quality and mapping and monitoring. Now we are offering this soil erosion modeling webinar, which is for 5 days. And then we are going to offer the other webinar, which is for the advanced, particularly on the advanced webinar on role of GIS and remote sensing in air quality and mapping and monitoring. That is for 1 month.
Okay. All of them are free of cost or not?
No, the webinars are not free of cost because there is a instructor fees included in it. So the webinars, particularly we offer webinars with like if it is 1 month, we offer for 999 or 1,499. But if it is for 5 days or 3 days, we offer for 99 or 199.
Oh, okay, okay, thank you.
Yeah, I share this webinar link with you because Dr. Avinash Astekar has asked me to put the webinar link into the group, in the college group. So that's why I did it. Yes, Nihar, please start.
Yes. Okay. Thank you, sir, for organizing this session webinar for 5 days. So basically, my name is Niran Sau, and I'm basically I already worked on soil, rivers, geology. Okay, so every aspect of remote sensing I have been already worked already, and so for next 5 days I only focus on the calculation of soil erosion uh, using the Russell model. Okay, so but for for today's agenda basically is to know about soil erosion and the models. Okay, and then we're gonna discuss some how to calculate what are the different formulas to calculate the soil erosion, and from the next day onwards, uh, we'll download datasets and process all the calculations. Okay, so before I'm going to start the webinar, uh, can you please all of the attendees, can someone share their work, why they join in soil erosion, if they are working or working in soil erosion field, or just curious about this remote sensing aspect? Can I know your
Yeah,
background and all?
so that would be great for us to understand the audience background particularly. So please do introduce yourself and do let us know like why did you join this webinar particularly? Is there any goal behind it? So please do so.
Hello, sir. So my name is Abhijit Pandey, and I have done my master's in geoinformatics. And in my final year project, I worked on digital soil mapping, using remote sensing and prediction of the soil. So I already know some terms for the soil, like I used Scorpion method, and that were my environmental covariate. And through that, I used a random forest method to predict where the particular soil may be present. So I already did this project, so just wanted to learn about what is the Russell model. I already my few of the batchmates already done this project. So I already know some of the terms like Russell model and all, but I want to get deep knowledge how it is, how we are gonna do it. So this is my introduction.
Hello everyone. My name is Shubham Mishra. I'm from Delhi. By background, I am an urban planner. I teach applications of remote sensing in GIS in School of Planning and Architecture in Delhi. So I've been working with. I mean, I have been a GIS professional for almost 2 decades. I have not really ventured into soil sciences as such because that's not really my subject. I deal mostly with urban remote sensing. And of late, my area of interest is actually built heritage and geoinformatics. So that is slightly in a different direction. While why I'm interested in soil erosion is because I also do site related work, as in site design, because of my background in urban planning. So I do master plans and ecological planning for sites. So in that, understanding the soil erosion, etc., I thought would make a lot of sense. So I'm here, and also as one of my I work as a consultant. So one of the recent works involved a watershed in Maharashtra where we were trying to do. The client had made certain interventions in the watershed, and we wanted to see analyze things like vegetation condition index, etc. So we were also looking at soil erosion there, and we were using the Invest workbench, which is a tool created by the Stanford University that also uses the soil erosion model, the Russell model. But since I did not have much background, so although I ran the model, but I did not have a I wanted to have a deeper understanding of what I was doing. And around the same time, I found this webinar, so I thought it would be a good idea to join it. Thank you.
Great. So I would like to have a one-to-one conversation with you sometimes. So I think we are connected on the LinkedIn.
Yes, we are on LinkedIn, and we are also on WhatsApp. So
Okay. So we'll connect on WhatsApp or LinkedIn, and then
sure, sure.
I would like to know more about it because there are two things. One is we have got one of the projects from Chennai, and we are working on related to urban planning only.
Okay.
So let's see how we can collaborate on that.
Sure, sure,
Yeah,
sure. Thank you. I'm very happy to be here.
yeah. Thank you. Please introduce everyone.
Hello, sir. Good evening. I'm Tony Maditto. I'm doing PhD from IIT Jodhpur. My topic is sustainable urban planning. Uh, I joined out of curiosity because I want to understand about environmental issues. That's why I am joining here.
Okay, that is something we love to hear because if people understand, okay, this is something which I should learn more about it, or like curious about learning those things. So we are happy to have you here. Yes, please introduce everyone. We have the people from Haita Hive also, right? I think Supriti Kar is there, Jabbar is there, and one more guess, I guess. Yeah, guys, please introduce yourself. Jabbar, Sajaldeep, Supriti.
Hello, good evening, one and all.
Good
Good
Hello,
evening.
evening.
my name is Dr. Raju. I am from Hyderabad. I am working with environment impact assessment uh, consultant as a geologist. My role is uh, here hydrogeology and land is land cover uh, expert for EIS studies. So I want to learn things how to prepare soil erosion maps. So which data need to know how to collect for the soil erosion studies. So that's why I want to hear join here. Thank you.
Thank you, sir. Rasmi and other people, please do introduce yourself. Then we will start the session soon. Okay, Supriti is outside, so she cannot unmute herself. But if anyone else want to introduce themselves, please introduce. I think I didn't introduce properly myself. My name is Nagendra. I'm the founder of Haitav and Matrix AI. So we have two companies. One is in India, one is in the US. The Indian company, particularly, we started just to serve the geospatial community, particularly worldwide, where we can actually offer the courses within the affordable price, so that everyone who want to learn and upgrade themselves into GIS development, they can actually learn from the Haita Hive itself. And we started the web series particularly for the webinar because sorry, we started the series of webinar because of the people. Still, there were people who actually cannot afford courses, even if we are offering the affordable price, but they cannot afford the price. So we started offering webinars so that they can actually have something in their resumes, in their portfolios that okay, I have joined this webinar, I have submitted my assignment, and I have got the certificate out of it. So that's why we started the Heta High. Yes, we don't run any profit revenue in out of it, but we have one of the company in US which is Matrix AI, where we offer the hazard risk analysis reports, and we right now we are in the seed stage and we have acquired more than 7 customers, and we have onboarded around 10 team members, particularly director of sales, CTO, CMO, CXO, and CEO. So that's what I do, particularly in Matrix AI. I have 8.5 years of experience, and my experience is combined in all these sectors, particularly navigation, where I was working on the GNSS and GPS, particularly with the uh, at the Harvard. And after that, I have worked with the NABARD for 3 years, and I have worked on the several projects. But I have worked closely with the Punjab Remote Sensing Application Center, Maharashtra Remote Sensing Application Center, and Uttarakhand Space Application Center. So these are the three which I have particularly worked with them. Other than that, I also have worked with the OSAC, which is Odisha Space Application Center, where we develop a machine learning model for them. So this is my background. Nihar, if anyone want to introduce themselves, they can introduce right now, or we are going to start the session in 2 minutes. If you have any question for me, you can ask right now.
Okay. Okay. So let's start the session. Some. Some
Before the session, Nihar, I would be on the call, but I would not be able to unmute myself. I would be available in the chat itself. Okay, because I have one of the meeting, so that is in person in Hyderabad. I'm going to meet that particular person, so please take care of the questions. I would be available on the call, but I would not be unmuting myself.
okay, sir. Okay. So let's start soil erosion. What for the first day we only learn about soil erosion, and some models how this Russell model came. Some models, and we also discussed that how those models are basically using in real world projects. And also we review some research papers. Okay, I downloaded almost 12 papers selected. Basically I have more than hundreds of papers in my actually folder, but I chose 12 research articles to show how to work on the soil Russell model, and what you can build, and you can publish some research on this. Also let me share you that what are the things we're going to discuss in this 5 day, so that you have already know that what are the topics is going to cover. And so you have the curiosity um, in you, so to join daily. Okay, so in 5 days, okay, we in basically 5 days, uh, we're gonna build a soil erosion model. Okay, soil erosion model. And the soil erosion model, basically in the Russell model, there are various factors. So each factor is basically, to calculate each factor, there are the various GIS, QGIS, we use QGIS for this calculation. So in every factor, in every step, we are going to use some tools. Okay, so that is very important, because if you don't know how to calculate LULC, let's say, if you don't know how to calculate LULC, so here we're gonna discuss about LULC calculation. We calculate LULC, then classify those. We classify DEM files, flow accumulation and all. Then we're gonna work with some point data sets, also some interpolation techniques. Also there are various things we're gonna discuss in this 5 day course. Okay, there are a lot of information and lot of things we will cover. Okay, so for now, for today's session, let's start about what is soil basically. All we
Uh,
can know
before
that.
that, before that,
Yes.
Nihar, do one thing. If you are going to use any data sets today, please do share the data into the chat, or with me. I can send over the email. And for tomorrow, if we are going to use any data sets, so please do share with me by today evening only, today night only, so I can share with the all the participants, and they can actually work on the live data sets tomorrow, or they can
Okay.
practice.
Okay. Okay. Yes, Ajay. So for today, I already I'll share some research papers which we follow to calculate the Russell models, and uh, by tomorrow I'll share all the data sets which are gonna work. Okay. So first thing is that what is soil? So we already know that the soil is a natural, dynamic, and living system formed by our surface. Okay, but uh, what is soil? Basically, soil is a mixture of these mineral particles. Okay, which will formed by erosion. Okay, the years of erosion activity by agents, some agents like river, glacier, water, and then those particles become minute and formed soil. Okay, then mineral particles are there, then there are organic matter also. Okay, so decomposed matter, all the plants and animal matters. Okay, there are also water is also present there. Okay, so here if you work in the soil, so you can calculate the soil moisture content. Okay, so basically soil moisture, and soil moisture is calculated using SAR datasets. Okay, so recently launched NICER. Okay, so for that the water is also present in the soil, then air present or air pockets there. Okay, and some living organisms, all these combinedly form the soil. Okay, so here you can see that to form 1 inch of soil, okay, naturally, not by any like in the sense human intervention or something. 1 inch of soil, to form 1 inch of soil would need around 2,500 years. Okay, that is how extensive and precious the soil is. Okay, and we already know that soil is a non-renewable resource. Okay, so it is not unlimited present. Okay, so we have to monitor, we have to preserve, in whatever cost we have to preserve that soil. Okay, then also 25% of Earth's biodiversity lives in soil. Okay, from bacteria and some centipedes and all the features. 25% of Earth's biodiversity. Okay, then 95% of food depends on a healthy soil. Okay, to grow our agriculture products, also to grow or larger trees, we need soil. Okay, so this is how important the soil is for our human life also, and for the environment also. Okay, so how soil is formed? Basically, there is a term known as clorpt. Okay, CLORPT. So basically this is the CLORPT factor is basically um, responsible for creating the or formation of soil. Okay, first one obviously the climate. Okay, the precipitation factor there, temperature, the wind, all the climate factors is there, the ice cover. Okay, all these required to main thing is that climate. Okay, then we also need organisms to basically alter some let's say nitrogen, phosphorus, potassium, to alter or balance the ratio, also to basically influence some pHs. Okay, or to basically to or to moisturize or soften the soil, so that the air and water is percolate there. Okay, so organisms play a great role in forming the soil. Then we have the relief. Okay, we already know that higher the relief, the more the erosion. Okay, but if the relief is very less, okay, so then there is we can get some soil formation. Okay, thick soil formation. If the soil, if the slope angle is very high, then we get very thin soil formation or no soil formation. Okay. Okay, then we have parent materials. Okay, the parent material actually directly influence the composition texture. Like for if you for example, in the Deccan plateaus we have black soils. Okay, So because of the Deccan trap or the Deccan volcanism erupts there in the million of years back. Okay, and after that solidifies this Deccan volcanism. Okay, Deccan volcanism. So after that there is formation of black soils. Okay, because they are directly formed from the igneous rocks. Okay, or the volcanic rocks basically. And if you say about let's say if there is a granitic, so in the granites we have silica, potassium is very high, so we get potassium rich soils. Okay, if in a parent material there is limestone is very high, so we can get the calcium, the carbonates there is basically. Okay, so this is why directly influence the parent material directly influence the formation or the type of basically the type of the soil.
तो कैसे होगा
Yeah.
मेरे इसमें
Uh,
Please
by the way,
unmute yourself.
okay. Then also time, we already discussed that around 2500 years we require to form soil. So basically time is very much important. Okay. So this is combinedly known as the Clort um, extension or Clort factor to form soil. Okay. So this is the layer of the soil. Okay, so in the remote sensing, basically in the remote sensing we only calculate this much of information. Okay, the top layer of the soil. Okay, but if you want to calculate some soil profiles around 4 centimeter, okay, 4 centimeter depth, then you need the SAR. Okay, SAR data. In the SAR data you have various bands. Okay, so larger the bands, like in the your L bands, after your L bands um, you can you can know how in about 4 4 centimeter, I think 4 centimeter depth you can know the profile. Okay, so this is the soil profile basically, and the lower one is known as the bedrock. Okay, or known as the R profile, or this is known as the bedrock. And this bedrock is, in many years, this is going to disintegrate and form the soil. Okay, so after that the bedrock, we have parent materials in the C horizon. Okay, in the B horizon we have subsoils, then then we have elevation, then we have this topsoil. Okay, so basically this topsoil is very rich in minerals and also very soft, so that the organisms or the plants they grow rapidly. Okay. Okay, so now comes the soil erosion. Okay, so first let us discuss and learn about the soil erosion. Okay, the soil erosion, basically what is soil erosion is the detachment, transport and deposition of the soil particles. Okay, three things are very important here. Detachment, like we already know that all the particles are basically joined together or joined combinedly in the top top layer. Okay, so if the top layer is of sand particles, okay, the sand particles like this one, okay, there are sand particles, and sand particles are basically uh, the gap is very much there. Okay, so they are loosely bound, okay, themselves. Because there is no pressure exerting there, because they are in the top layers. Okay, and they are recently formed objects. So basically for this reason only they are not tightly bound. Okay, but if you talk about the clay, the silt particles, they are basically so small that they are electrostatically bound with themselves. Okay, so it is easier to move the sand particles than the clay and silt particles. Okay, and obviously the larger one is very much difficult to move the let's say boulder or larger size grains. Okay, so first thing is to detach from the original layer. Okay, then detach. After detachment, they are in the floating. Okay, if they are in the floating, we call it as saltation. Okay, or they are rolling around, so we call it a traction. Okay, so basically they are mainly transporting from one location to another location by various methods. Okay, if the particle is very small, okay, so it can carried away in the air and deposit very far away. Okay, but if the particle is very let's say sand, but coarser sand particles, so it can transport by only traction. Okay, if there is smaller grains of sand, so it can hop around like this. Okay, so it always saltation, the hop around and deposit somewhere. Okay, so for the deposition, either there is a plane is required or some obstacles. If there is some obstacles, so there only this movement can be halted and deposit and the deposition happens. Okay, so basically these things are important. So first thing is to detach from the layer. Okay, so this detachment can be done in various types. So the, for example, if rainfall is there, so the rainfall is falling on the surface layer, and after that the detachment is there. Okay, also by erosion also there, or it can happen like that if the wind is carrying some larger let's say larger grain. Okay, and the larger grain is dropped there. Okay, so here also some detachment can be also there. Okay, so first thing is that detachment. So mainly this is due to raindrop. Okay, because rainfall happens, then only the this process, the soil erosion process starts. Okay, okay, so these three things are mainly important. Okay, so why to calculate, basically why to calculate the soil erosion? Okay, so in what which type of data set or which type of let's say real world application we need this soil erosion? Okay, so to predict annual soil loss. Okay, so you can prepare let's say web app to calculate basically. So in your web app, yearly data sets have been there to the calculated soil loss is there, so that if any policymaker or anyone worked in like let's say site selection or urban planning, they can directly use that soil data. Okay, to let's say affect their decision making. Okay, then identify erosion prone areas. Okay, if there are some areas or some pixels you found that here very much erosion is there, so you can let's say prepare some terraces, some bounds. Okay, like you see already, you already saw in villages that they create some bounds. Okay, so that soil erosion is not going to happen. Okay, so this much of information you need if you want to calculate the soil erosion. Okay, so the assessment assesses sediment yield into river. Okay, so if you are, let's say, you are uh, uh, your job is to basically site selection. Okay, your job is to site select, so where the dam can be constructed. If the dam is constructed here, okay, what are the things that is going to halting or halted in the process of dam formation. Okay, so if there is dam is there, then this carrying the dam is carrying some water particles, and the water already carries some soils there. Okay, the soils are deposited here in the lower portion of the dam, and what is happening that in some years the depth is decreasing. Okay, so to know that where is the if you want to form some dams, some reservoirs, you need this soil erosion data. Okay. Also, obviously, to water quality. Okay, water quality, because if let's say a lake is there, or a pond is there, and there various, okay, your soil erosion is rapidly happening there. So what is happening that in that lake, eutrophication is going to happen, because the sediments can be deposited in the lower portion, but before that it will it will suspended for many, let's say many days on the top of the this water level. Okay, so there the oxygen cannot pass through this layer. Okay, and all the organism plants, they are suffer to basically they suffocate and die basically. Okay, so water quality is also a very good to know the water quality of, let's say, lake or pond. You have to you have to know how to calculate the soil erosion part. Okay. Okay, so there are basically various type of soil erosion. Okay, some are splash. First one is your splash erosion or raindrop erosion. Okay, so splash, in the splash erosion, basically also this is known as raindrop erosion. We already discussed that when the rainfall is the water droplets from the rainfall, okay, they are falling on the surface. Okay, what is that? They are quickly in the high velocity. When the this raindrop is in high velocity, it is impacted on the surface of the soil. Okay, and there the splashing is there. Okay, there is a splash there. Okay, so after that there are various soil particles. Okay, soil particles get detached. Okay, so this is known as splash or raindrop erosion. Next one is your sheet erosion. Okay, so sheet erosion, basically you can see that this thin layers of let's say your thin layers. Okay, thin layers can be formed in the topsoil. Okay, when there is a runoff because of rainfall. Okay, uniform removal of topsoil. Okay, across a slope, obviously slope, by shallow surface water flow. Okay, then there is real erosion. So basically, then the seat erosion, and then real erosion, then gully erosion. So basically, the depth and the wideness is basically increasing. Okay, so in the seat erosion, there is uniform removal of the soil. Okay, after that, there is real erosion where small and concentrated channels, okay, have been created because of this rainfall runoff. Okay, when the rainfall is happening on a surface, okay, then the water channels are being formed to basically so that water can flow from one direction to another direction. Okay, so if the size is very small, it is sheet erosion. Then this one is your real erosion. Okay, after that you have larger let's say uh, Utai valleys. Okay, here you have gully erosion, large deep channels. Okay, basically greater than 30 centimeter, and this is your less than 30 centimeter. Okay, so, and in every, if you are seeing a river channel, a massive river channel, or let's say a river channel, so basically they are started by this seat and real erosion only. Okay, then the channels are getting wider because of the erosion, and now we can see there are various rivers can flow in that channel. Okay, next one is stream erosion. Okay, so stream erosion, so when let's say this is your river channel. Okay, let's say this is a reel is formed or a gully is formed. When the gully is formed, basically they are straight in your uh, size. Okay, so if they are in like small, let's say there are small curves there. Okay, so when water is going to flow here, what is happening here, that in let's say in the lower banks, in the inner banks, okay, the force is basically restricted, and in the outer banks there is erosion here. So here in this part erosion is happening, and those sediments can deposited here in the inner banks. Okay, so you have erosion here and deposition here, and likewise this channel is shifted towards this. Okay, so this is basically stream erosion. And then we have wind erosion and let's say glacier erosion and other things. Okay, but important is that in the Russell model, because we are mainly calculating the Russell model. Okay, so in the Russell model, we are calculating the soil erosion. Basically, the seat and real erosion we are basically calculating. Okay, we are not calculating gully erosion and other things. We're basically focusing on this seat erosion and this real erosion. Okay. Okay. So before dive into the model itself, the soil erosion model itself, first we need to know about the difference between erosivity and erodibility. Okay, there are two terms, erosivity and erodibility. Okay, so erosivity, when there is erosivity, okay, it is directly linked to the rainfall. Okay, rainfall. So you can say like that, rainfall erosivity. Okay, so here is the capacity of rainfall to cause soil detachment. Okay, this is the erosivity. If there is more rainfall for let's say greater number of time, okay, let's say for 30 minutes, let's say for 1 hour, okay, longer duration. Okay, so this can lead to soil detachment and soil erosion. Okay, that is this erosivity. Okay, and erosivity, in the erosivity basically it is calculated the reflect the kinetic energy of the raindrops. Okay, the kinetic energy of the raindrops. Okay. Okay, the unit basically this hectare hour per year. Okay, and okay, so this one, see, E30. Okay, this is EI30. So basically this EI30 is basically calculated that, so there are, to calculate this erosivity, basically the capacity of rainfall, okay, to cause soil erosion. Okay, there are various indices there. So one of the indices is E30, EI30. Okay, in the EI30, what is we calculating that? Obviously, we are calculating the kinetic energy. Okay, because kinetic energy can lead to the erosion itself, and we're going to calculate the maximum 30-minute intensity per storm. That means we calculate only the 30 minutes, in the 30 minutes how much of rainfall is going to fall, or how much runoff is there. Okay, so this is this okay.
Please do ask any question. If anyone does have any question, they can ask in the chat. They can write the question in the chat. We will be happy to answer. Nehal, continue, please.
Yeah, okay. Okay, so the then obviously the storm intensity is there. Okay, and how this rainfall is calculated, rainfall, mainly the rainfall are calculated by the gauge stations. Okay, there are various gauge stations are there in the covering all the area of the India. Okay, so the gauge station are, in the gauge station basically this rainfall data is being collected. Okay. Okay. Then what is erodibility? Erodibility basically related to the soil erodibility. Like this one is rainfall erosivity. Here the soil erodibility. Okay. The susceptibility of the soil. Okay. The how much vulnerable vulnerable is the soil to erode. Okay, so that it can erode. Like if the soil is very loose, okay, so it can erode very quickly. Okay, that is that the susceptibility of soil to erosion by water. Okay, how easily the soil particles are detached. So basically these are mainly two important factors, okay, to for calculation of any soil. If you're calculating, if you're working in any soil erosion models, or you can soil erosion, so you have to remember these two terms, erosivity and erodibility. Okay. Okay, so we have rainfall records. Okay, in the rainfall records, there are hourly data. Okay, so in the hourly data, then we can calculate the 30-minute storm. Okay, and we can okay. So back previously, actually, what is happening that they are directly use some gauge stations, and from there they are extracting some data sets, and the data sets are calculated, okay, manually using excel and all. Okay, okay, for that basically first this is generated that this USL, okay, USLE, universal soil loss equation. Okay, so basically this universal soil loss equation is being created basically to calculate the soil erosion. Okay, so here the USLE, okay, what is happening is that this is basically a erosion prediction model. Okay, this is basically predicting the erosion, what how much erosion, because directly you cannot find the data that how much is soil is being going to erode or loss. Okay, so basically it's basically predicting, okay, the prediction model for estimating long term average soil erosion. Okay, what is this soil universal soil loss prediction model for the long term average of soil erosion? Okay, we basically calculating some numbers to basically replicate the real world scenario. Okay, from the basically this is one thing is that from the this what is that? Yeah, seat and real erosion. Okay, the seat are we were
S-
not calculate.
Sir, may I ask you one question regarding that
Yes, yes,
universal soil loss equation?
yes,
So,
please.
whether this model is applicable for coastal area, desert area, or maybe normal plain area, or maybe Gangetic plain, or maybe Deccan plateau, something like that. So, could you please elaborate with an example, please? Thank you.
Yeah, okay, okay. Okay, we will seeing some examples in the this is articles basically, but yes, you can calculate in, if you want to calculate for let's say a district, you can calculate for a state, you can calculate for whole world itself at once. Okay, there are papers, the basically nature articles are there, basically they are calculated for a whole world. Okay, so you can calculate the smaller district level, villages level, to basically the larger scale, okay, in the world or India itself. But the main constant is the data set. Okay, if you have, let's say you are calculating for your village, but in the village the rainfall data set must be there, if the rainfall data set is available, if the gauge stations are available, okay, if the soil type is available, then you can calculate easily. Okay, so you can calculate for any area, any scale of your area. Okay, we'll be seeing some
Yeah,
examples.
particularly you can use the Russell model for both of the like coastal and Gangetic inland regions also. Okay, so there is combined with the GIS and remote sensing. In anywhere, if you have the sufficient data sets for it, you can use it. It is not defined that okay, you the Russell model only use particularly for the coastal, particularly for the Gangetic plain. You can use the Russell model, particularly if you have the data sets for the region.
Do agree with you, sir? But while talking about
Continue, Nihar, please.
while talking about coastal ecosystem or maybe floodplain, the parameters may be diverse. The parameters may be differ. So in that case, I mean, what the acceptance accuracy in this particular model? So
Yeah.
I'm talking about in that context, if it is possible to answer.
In the
Okay. Okay.
see in the model when we use the Russell model for soil erosion for coastal or cognitive frames, and if we have the difference between the parameters of the area, obviously there would be the difference. The further processing in the model itself, which we will cover for the next 2 days, and we will show you how we can use the different parameters in different regions to calculate through the Russell model.
Got you, sir. Thank you. Thank you, sir.
Okay. Okay. So we'll see some examples in with some research articles. Okay. So basically, this universal equation. What the need for this model is that we cannot calculate we cannot calculate using some like uh, direct field data set. Okay, we cannot calculate, and if you can calculate, it is very time consuming and very labor intensive works also there. Okay, so to basically to calculate for larger areas, okay, or so there are some models there. So what are the models basically? The models are basically some equations. Okay, some equations are there to be basically uh, means calculate or to predict the real world scenario in lab or in the computer itself. Okay, so through these models, so we basically simulating real world scenario. So that's why only every model is can be any empirical model, okay, any statistical model or any machine learning model. They have some advantages and disadvantages and also some accuracy or errors. Okay. Okay, so here this is the universal soil loss equation. Okay, so and for this soil erosion data or soil loss data, basically the seed and real erosion are taken into consideration. Okay, so this is A, and these are all the factors basically. Okay, so this is the R factor. Okay, this is the K factor, LS factor, C factor, or P factor. Okay, what is the A is basically the average annual loss. Okay, average annual soil loss. So we are basically calculate the averaged annual. Okay, so we have annual data for this. Okay, so then R is the erosivity. Okay, rainfall erosivity factor. Okay, then what is K? K is the soil erodibility. Okay, well, erodibility is related to the soil. So this is your K factor. Okay, then the your LS factor. LS factor is basically slope length gradient. So basically that is your topographic factor. Okay, this one is your topography factor. Okay, then this is the crop management factor and this is your conservation practice factor. Okay, so basically these are okay, basically these two terms are basically uh, uh, calculated, basically these two terms are one basically. Okay, for some for many areas. Okay, so we have only these three data set. Okay, we'll be seeing that. Okay, so this all okay. I think okay. This is your rainfall erosivity. Okay, soil erodibility. Then this is your slope length. That means this is basically topographic factor. This is your I think this is crop management. Okay, why here the crop management is there basically if there is let's say tillage is there or let's say uh, a recent tillage action is going happening there. Okay, so that is more vulnerable to erode. The soil is more vulnerable to erode. That's why this is your management factor. Okay. Okay, so First thing is that we have this rainfall runoff factor. Okay, we already know that this rainfall runoff factor already seen that. Basically we're calculating the rainfall and some indices, and basically this the rainfall, the 30-minute rainfall interval. Okay, in the soil basically this is directly in related to your soil texture and soil type. Okay, so if you have soil type data, if you have soil texture data, then the k factor is integrated in that. Okay, and the ls factor is that like for example, the if there is uh, uh, greater than your 9% slope is there. Okay, and if there is slope length of let's say 22.13 meter. Okay, so this is we can classify this either that is going to a high risk erosion area or a low risk erosion area. Okay, so we basically have to download the data set and process to define these factors. Okay, and then we have to classify from 0 to 5, let's say 0 to 5, that it is highly high affected or lowly affected or in between. Okay, so this is basically firstly this is applicable to USA only. Okay, the ASAL model is basically started by the USA, and so the American for the and these all the formulas and all the data sets are only calculated for uh, USA condition only. Okay, but USA condition is very different from the Indian condition. We have here monsoon is there. Okay, so uh, okay, we'll see that. Then this is simple. Okay, and we can field validate this. Okay, and we can do some validation also there. Okay, okay, and this is very much your very popular also this model. Okay, rather than other models. But what is that, does not predict deposition or gully erosion. Okay, gully erosion or deposition is not calculated here. Okay, we assume uniform slopes. Okay, and this is for calibrated only for the US conditions. Okay, that's why there are various data set or various models come after that ASAL model. Okay, so after the ASAL model, basically this is another model known as modified universal soil loss equation. Okay, in that actually this is in 1965. Okay, so from 1965 to now 2026, there is various papers being published using this Russell model. So for that reason only, actually for every region, scientists are already calculated using some field validation. They are already calculated and set some equations for your region. Okay, so if you are calculating erosion data or soil erosion for your area, so your area is unique, so you have to go through literature to know that what equation is applicable for your area. Okay, so the William, what he did that, he did not include the rainfall data. He replaced the rainfall data with runoff data. Okay, so runoff data is basically calculated using this SCS curve method. Okay, SCS curve method, and we have runoff data set for various points. Okay, so he taken the runoff data and this runoff volume and rate flow. Okay, and included in the R factor. Okay, he only twisted that, but actually the ASAL model is basically actually much more useful. Okay, and for the means to tackle larger areas. Okay, to tackle larger areas or to or to apply this model in larger areas, basically again the USDA again modified in 1997 to this revised soil loss equation. Okay, so from the 1997 to 2026, this model is still very much popular. Okay, so here he just modified some algorithms. Okay, so basically here in the asal models, basically what is they did that they have to uh, collect the data from the field, and then they have to calculate each and every equation through hand or through Excel sheet. Okay, but to apply for larger areas we need something else, something like computer models. Okay, so then it can auto calculate all the areas, and the time we is very less for the calculations. Okay, so for that reason only the revised universal model is being generated. Okay, so here you have this R factor, improved R factor. Okay, we'll be seeing that. Then this time varying K factor. Okay, and also all other are basically same only. Okay, so you have this rainfall erodibility factor. Let me first show you some research articles. Okay, okay, let's see. This is a soil erosion modeling review article. Okay, so this review article is basically is from 2021. Okay, by Borelli. So here you can find that he actually combined all the data sets and all the models that are applicable for soil erosion. Okay, so 1 minute first. Okay, okay, see, these are all the models. Okay, here you have in the top you have Russell model. Okay, basically they are used 17% of their papers or which they reviewed are of this Russell model only. Okay, then you have Asal model. Then you have some software based models or empirical models like this SWOT model. Okay, then you have this WEPP model. Also there is muscle model also there. Then you have also some modified sad sediment yield ratio to calculate this Russell SDR and Asal SDR model. So these are all the models are available, and after the machine learning boom, then there are various models you can incorporate to calculate the soil erosion. Okay, and if you see this chart, you can see that this Russell model, how popular is the Russell model. Okay, various data sets are calculated using this Russell model, because this can be this is first thing is that this is efficient and has a good accuracy. Also also that this is slightly less time consuming and easy compared to other models. Okay, that's why this is very much popular, and you can see that. And after 2017 also there are various papers, like I have many papers from 2025 to 2025 to 2026. They are also published using this Russell model, and they are published in, see, Science of Total Environment, so high impact journals. Okay, okay, okay. So see here, geospatial modeling and mapping of soil erosion in India. Okay, so see, this paper is calculate this in this paper he calculate basically for total India. Okay, the land use land cover for total India, the soil classes, and they put into those equations. Okay, to calculate. See, basically we have this is the workflow. okay, for their study. So let me discuss. Uh, okay, see this graph. Okay, this map. Here is the basically mapping of erosion severity classes. Okay, we also calculate the this type of data set. Okay, but I want to discuss you that I want to discuss with you all that which for which data area we going to calculate. Okay, let for example here see. Okay, let me zoom this map. If you see here that this catastrophic is in red color and this severe is in orange color. Okay, so basically this area is basically lesser severe category. Okay, so we can skip this. So here you can see that this basin, so this is basically Brahmaputra river. Okay, and this is your Assam, this is your Arunachal Pradesh. Okay, and this is your Brahmaputra basin. So this Brahmaputra basin in India is highly highly named. This is the most um, severe to soil erosion. Okay, this is Brahmaputra Valley, Assam. Okay, so basically here um, uh, not Dibrugarh. I forgot the name. Okay. Okay. Also, here you can see that this Ganga basin, okay, and the UP Bihar areas. This is in some areas high erosion is there, and in some areas, let's say severe erosion is there. Okay, this is catastrophic red in color. This is severe. Okay, so this also very much highly in the severe category. Okay, also here also there. Okay, so from this map you can select your study area, you can define your study area. Okay, and then you can calculate let's say for your state, or let's say for your district you can calculate. Okay, here Dhemaji is there. Dhemaji is the mostly affected, so we can try Dhemaji also. And uh, okay, so here also if you see that in the western ghats, okay, and in the eastern ghats in some areas also there are very much okay, in this severe category, but not that much as compared to this Ganga basin, this western Himalayan region, and the Brahmaputra basin. Okay, this is the Meghalaya. Okay, Meghalaya is also because the slope is very high in this area, in the Meghalaya area. So for that reason, this is also in higher category of soil loss. Okay, and the Bangladesh is also very means soil erosion very active there. Okay, this is also very affected areas, Bangladesh also. Okay, so we can do either for let's say some district in northwest Himalaya or some district in Assam. Okay, so you can ask any question or can suggest which area, for which area we can uh, calculate the soil erosion. Okay, anyone want to say something?
Hello,
Sir,
hello.
in
uh, yes, please, Abdul.
Yeah, I have a question regarding that the USLE FL model and the Russell model, where we are not considering the soil type. We are just considering the soil erodibility and erosivity and the rainfall intensity and all. We are not considering any type of the soil
Yeah,
like
in the
that.
soil erodibility, basically the soil erodibility is dependent upon the soil type and soil texture. Okay, so I have to integrate the soil type in the in the K factor.
Okay.
Okay, so anyone?
I want to ask one question. The data will use for this particular model. So what are the data sources for these? Like,
Yeah.
where do we get this data from?
Okay. So basically, what we will see that uh, for this only for today only we will only discuss the model and what are the data sets to calculate. Okay, and some formulas we're going to discuss. For the data sets, what I am planning. Let me. Okay. Okay, what I'm planning that I'll be sharing you the links how to download the data. I'll be showing you also show that you that where to download the data. Okay, where the sources you can download the data, and then we can process the data sets. Also, after processing the data and preparing the layer, also I will share some more area more let's say data set. Okay, let's for example in the rainfall we will discuss rainfall in the next class. Okay, and in the next class other factors. Okay, we'll focus only rainfall in the next class basically tomorrow. In the rainfall you can either directly use the gauge station data. Okay, basically there are some stations there where you can download the data set, hourly data sets. Okay, so we're gonna calculate hourly data, then convert it into the annual data set and do interpolation to basically prepare a map. This is one type. But also you what you can do, you can because if they say you are working in the Assam area or let's say India, for whole India. Okay, so for that this is very difficult to to download for all the stations because I think around 16 okay 16,000 or some stations are there. Okay, so it is very much difficult to calculate all the data set. So for the larger data set we are basically using some satellite sensors. Okay, satellite sensors like your chirps data set, and chirp data sets come in the netcdf format. Okay, netcdf format. So I also share you that how to calculate the or download data from chirps, and also another one. Okay, okay. Then in the netcdf, how you convert that to raster, and how you can downscale the data, and you can your start your okay, you prepare your layer. Okay, I will share other sources so that you can use accordingly which source you need. I will list all the layers. Okay, and the data set all the data sets that are available that you can use. Okay, so I'll be sharing in the upcoming days.
Okay, sir.
Yeah, 1 minute please. Okay, let me read some comments. Okay, so what are the areas you are proposing?
So whether we
For
may focus on Indian two biodiversity hotspots, considering Northeast India and Western Ghats,
yeah,
if
so
possible, if possible.
okay, both for both the means you are trying to we are calculating for two areas.
Yes, sir. Then we can see a comparison between two areas, whether the different parameters which needs to be analyzed, and therefore we may take a better decision for that. Right, sir?
Okay, 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 can be we can do that also.
Sir, if possible, take Pench catchment area, Pench River.
So Pinch River.
Yes, sir.
Okay, okay, Pinch River. Okay,
Chindwara district.
okay, Chindwara in the MP. Yeah.
Yes, sir.
Okay. So in the MP areas, basically, that is vulnerable areas, but yeah, these areas also very. this area also very okay. So okay, so first let us calculate to know the processes only. Let us calculate for let's say any district of Assam. Okay, then then we can proceed some other aspect because if you already know the process, once you know all the processes, then for your other area you can directly calculate. Okay, this is okay for to start only. Let us choose any district, let's say Dhemaji. Okay, you can choose Dhemaji or any district in the Assam because this is highly high erodible area. Okay, as you can see. Okay, okay. So here also okay in the Sundarban also okay, yeah. Okay, so you can also not only you can also calculate the uh, means your study area. Okay, your study area can be yeah, bounded by some let's say administrative boundary for say district or state, or you can use your watershed boundary. Okay, like for example let's say the Pinch river. Okay, the Pinch river, this is Pinch river is flowing. Let's say Pinch river is joining with some larger rivers. Okay, so this is the outlet point, and here some watershed can be generated. Okay, so you can calculate the for this watershed also. Okay, and you can calculate for a state or a administrative boundary also. Okay, let's say for example if you are planning to calculate the soil or to monitor a dam. Okay, so you can put a outlet point on the dam, then it can generate some watershed, and for that boundary you can calculate your soil erosion. Okay, so you can calculate both the way. You can calculate for watershed boundary. You can calculate for the administrative boundary also. Okay. 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 So okay. So this is the map. This is very important map. Okay. So because we have some glance that where is maximum erosion and maximum soil erosion is happening there. Okay. Okay.
Sir,
And
one
see.
question is there. Sir,
Yes. Yes. Please.
yeah, we are calculating the susceptibility of soil erosion or past the amount of soil eroded in the past 1 year or something.
Yeah, past 1 year. For 1 year, how much average soil erosion loss is happening?
So, can we calculate the susceptibility also using this model,
Yes, yes. I will see you. I
like
will
the
show you
future?
some. Yes, I will show you some works here. Also, okay. So what you can do? Let's say you are using that. Let's say rainfall data. Okay, the rainfall data, the temperature data, the soil data. Soil data is basically same for let's say 4 to 5 years. Okay, then you can do what you can do that there are some climate models, like for example CMPI6 model. Okay, so that model can predict what is the rainfall or temperature in let's say 10 years, 50 years, 20 years, it can predict. Okay, so you take the data, put in some machine learning or deep learning model, so then you can predict that upcoming 5 years, 10 years, what is the soil erosion change that is going that will go will happen. Okay. Okay, let us review some papers and know the calculation parameters basically. Okay, so this is basically a paper for this China region. Okay, this Shanxi province. Okay, here you can see that. Okay, so this is the study area. Okay, so basically they are using your Sangji province, so that means this is the administrative boundary. Okay, So for that area, they are calculating basically with this formula. We already see this formula, R factor, K factor. Okay. Here, basically, what he concluded that he calculated from 2000 to 2014. Okay. Okay. See, these are the data sets. These are the calculations. Okay, these are the calculation formula for rainfall is less summation of alpha into d into, okay, and this is the value, and the calculated some factors. Okay, and some, okay, these are all the maps. Okay, we also prepare some maps, but here there are what he choose to they see for 2000, and in 5 years interval is he calculated and compare how much soil erosion is happened already. Okay, what is the change of soil loss where the see like here you in the 2000 here the soil R factor is maximum, but in 2014 here is the here is happening. Okay, so you can also generate some time series maps. Okay, and calculate this type of soil erosion uh, data. Okay, like we see already for the India. Okay, see high severe areas. Okay, same for let's say this is Jamuna basin in the Bangladesh. Jamun basin, sorry, Jamuna basin. Okay, Jamuna basin in the Bangladesh. Okay, so this is a watershed boundary. Okay, they choose for the region the a sub basin. Okay, see, we also you also can create this type of let's say methodological chart, and we also follow this, but with different data sets. Okay, different data set and calculation. Okay, let's say for example, there the rainfall runoff erosivity factor, they choose this calculation. Okay, from this let's say this paper. Okay, so here Babu et al. In this paper they are calculated in the lab about these numbers. Okay, so let us compare with some other areas. Okay, let's say for Godavari, this is for India, Godavari index, sorry, Godavari area, and the Godavari area, if you see, okay, see, this is the formula. Okay, if you want to calculate for let's say West Bengal, in the West Bengal there is Dwarkeswar basin. Okay, see, here is here is the formula for that. Okay, so the actually this formula is basically this formula is applicable in various areas. Okay, this is basically for a written formula, and these formulas are basically site specific. From this formula only they calculated and put some numbers here by solving some calculations. Okay, so if in your area already some papers or already some calculations is already available, you can directly cite that work, and you can choose your equation. Okay, but you, if you don't have some site specific let's say some basin specific or area specific calculations for your study area, then you can choose this one also. Okay, here basically this is the formula, and this is basically pi, basically your monthly rainfall, and p is the annual rainfall, because we are calculating average annual your erosion, soil erosion data. Okay, so for that region only, this is your uh, annual monthly rainfall and annual rainfall is there. Okay, okay, why I'm showing you this all these papers basically, what I saw in earlier let's say courses is that they will show you only some only one equation. Okay, and they show you how to calculate from those equation only. Okay, and that's all. But then again you want to let's say you want to start working for your area, then you find difficult way, because there are various different type of question equations are there, various parameters are changed already. Okay, so for that region, for the that context only, I am showing you all the equations, how the equations can vary for different areas. Okay, and how you can plan for your study area. Okay, see here, is for Western Ghats. Okay, and this is, see, this is 2023 paper. Okay, this is your 2026 paper. This paper is which area? Yeah, the in West Bengal area. This is 2026 paper. Okay, so this is relevant nowadays also, the Russell model. Okay, okay. So here we have for Brahmaputra basin. Okay, so we already if you want to work for Assam, Meghalaya, or let's say your Arunachal Pradesh areas, so basically this calculate you can choose this calculation from this paper. Okay, see, this is the your flow already same for all the. Okay, you can directly choose this data 79 for plus 0.39993. Okay, so first we have to download the data, then create annual rainfall value, then do IDW interpolation. Okay, then you can directly put your raster file into this equation and you can generate this R factor. Okay, but again, this Brahmaputra basin, for this Brahmaputra basin also, there are different equations. Okay, okay, see, the earlier one. Okay, see, you can either choose this equation for all your study areas, or for site specific you can choose this one. Okay, okay, see here again, Brahmaputra basin. Okay, 2022, they are using this equation. Okay, so basically this equation is calculated by Singh et al. Okay, in 1981. In 1981 he calculated from the asal. Okay, he calculated, and that value still used in the R factor to calculate the R factor. Okay, then if you are calculating soil erosion, what are other okay, we'll see that also. Okay, last one, this is your tropical river. I will share all these papers so you can follow along and you can choose. Please read all the papers from starting to ending, so you have a better idea. See here, he choose that equation only. Okay, so I will show you from this equation also, and how to calculate this equation also. Where is that? This equation also. Okay, because if you are calculating upper Brahmaputra, sorry, Brahmaputra basin. Okay, so this is the rainfall, and for that also, see, this is for soil erodibility. Okay, the soil erodibility, basically what is happening there? There is your factor depends on soil shear strength, texture, aggregate stability, organic matter, all those things. Okay, so for that reason only you have to calculate this calculation, and you have to calculate for sand, for clay silt, organic matter, and hill sand. Okay, so high sand. I told the high sand. So high sand. Okay, we're calculating sand, we're calculating clay silt. All we're going to calculate from the soil data set, soil type data. Okay, from the soil type data we're going to calculate, and see, each layer has its own calculations. Okay, that's why we choose. That's why 5 day range is chosen to only to calculate the soil erosion, because this is very see how much work is there. Okay, to basically prepare one layers. Okay, then this one also. This okay. Let me compare you with different papers. Okay, so this one is same. Okay, Okay, see here. Yeah, here you have different one. Okay, so basically this is your M, this is your ABC, and this is showing you what is going to calculate. Okay, and also, so for that region we have to download the soil type data for our region. Then only we can calculate the data set. Okay, if you're going to if you see for China, they are calculated using. Okay, so I will show you how to calculate all these things. Okay. Okay, then another one, k factor, then is your ls factor. So in the ls factor you have the slopes. Okay, so first thing we have to download the slope data, dem data. Then we have to calculate flow accumulation. Then in the flow accumulation we have to using this formula we generate L. Then using this formula we generate S. Then we calculate ls layer. Okay, so this is how intensive work we gonna do in the next 4 days. Okay, and other factors are basically in the C factor, and your P factor are basically taken one basically for all the areas. Okay. Okay, so but basically for this area, okay, these factors we have to we have to calculate LULC. Okay, so you can directly you can directly download LULC data set, but for this webinar we gonna using the QGIS SCP plugin, we gonna calculate LULC classification also. Okay. Yeah, okay, I will share, I will definitely share all the uh, areas. Okay, all the research articles. Okay. Yep. Okay, so okay, so
Excuse me, sir.
yes, please.
I'm sorry to take you back. I have heard you say that the C factor and the P factor we are going to use one. Is it because we can't get the data set, or I've come across studies that C factor, I've seen others using land use, land cover, and then some use the NDVI. And for the P factor, I think I've seen for those who really go to the field, they use some management practices which are there but normally ones. So why are we using one in this case, especially for cover management? And at what point do we use one, or we actually have to use the actual data set which is there?
Yeah.
Thank you.
Yes. So basically, we actually we have to calculate in this for this webinar. We gonna download LULC and DVI data, or generate LULC and NDVI data, and then we integrate in these factors. Okay, but one actually incorporated in basically ASAL model. Okay, back then basically they are calculated using Excel sheet only, and they have a simple formula that if a surface is your less than 9% or 10% slope. Okay, and if the that uh, one um, the slope length. Okay, the slope length, if that is your 22.13. Okay, they simply do put one in that. Okay, for the simple calculation. Okay, but that is not that is not in high accurate. Okay, so for that reason only, for the remote sensing work or GIS work, for the C and this P factor, we want to calculate NDVI also. I will show you here. See, this is after this LS factor, we want to calculate this NDVI. Okay, and from the NDVI we're gonna calculate this C factor. Okay, and the P factor we're gonna calculate from the LULC. Okay, then only we can calculate the soil loss rate. Okay, but back then previously in the ASL model, basically they are calculating using this one, which is not accurate, but it can give you 80% accuracy. That's why.
So I have another question. Like,
Yes.
if we validate through different models and thereafter, if you're trying to find out the ground reality or maybe field validation, so how does particular model is giving us accuracy in terms of ground truthing? Thank you.
Yeah, means you're concerned about the ground truthing. If let's say for a paper you are calculating soil erosion, then you have to go to the field and to validate it that if the value is same or not.
Exactly. I mean,
Yeah.
it has to be plus minus 5% can be considered, but after that, I mean, how does the model is fitted on the ground condition? So that is my question.
Yes, yes. So actually, if for any reason, okay, if the ledgerine is slightly large in region, you cannot you cannot calculate in each point. You cannot calculate. Okay, so for that reason, basically for a region, you can calculate this using this JS technique or using this Russian model. Then you can go to the field. You can use the ASL model. Okay, the that one how they calculate. Okay, they are going to the field. They are taking the gas station data. Okay, they quantify the soil erosion. Okay, and then you can validate from the uh, that data to your data. Okay, how you can validate? You take the GCB point. Okay, and for that point you calculate some value, and then you can verify that yes, this pixel is let's say giving 20 hectare per year, and your value is let's say 19 per year. So that's how you can validate. And there are papers also here. There are papers also how they are actually going to the field and taken samples, and then they verified their work. But greater than 80% is very good.
Got you. So you'll demonstrate all those things in the next 4 days, right?
Yes, yes, yes. Definitely,
Okay.
definitely. We'll
And so,
see.
and so one more thing, like whether you're going to share the videos with us? No.
Yes, yes.
Okay.
Uh, Videos, PPTs, and datasets will be shared. Okay.
Thank you so much.
After 5 days. Okay. After completing 5 days, we'll share the data. Okay.
Another
So
question, sir. A
yes,
simple
yes,
one.
please.
Okay. So under the formula for this soil erosion, which I have seen it multiplies the factors, the 5 factors. But then there are actually other studies that give weights to these factors, and then they are aggregated using the weighted sum. So won't can't that make the two studies a bit different, assuming I've used the multiplication one just like the model says here, and another study that has actually given these factors weights and then aggregated them? At what point do we use those two different formulas? Thank you.
Okay. Basically, there are various uh, formulas, various types, various techniques are there for a simple calculation of soil erosion. Okay, there is not only this Russian model and this formula, or these steps are not bounded that we can calculate only using this step only. Okay, there are various steps also. Okay, so if you are calculating, let's say by weighted average. Okay, so you have to choose the equations back. Okay, starting from your work. Okay, you choose your equation, because for that different equation and different uh, models are there to calculate this weighted average. Okay, like for example your ASP, you can integrate like ASP, you can put some values like let's say you can, K factor is very highly applicable for your area, so you get high weightage to that one only. Okay, but actually you have to first, you have to do some let's say literature review, and then you can choose for your area, or for your how, what accuracy you need, then you can choose what which step you can incorporate.
Thank you.
So basically this C and P factor are basically is this C factor is basically crop management factor. So what here we evaluate is that the effect of crop cover. Okay, let's say there are various crops, or let's say there are let's say trees are there, so their root system is very widely, they use their roots and they tighten the soil. Okay, so if there are crops is there, if there are trees are there, so this that is lesser likely to erode. Okay, but if there is no crops there, not nothing is there, then that is high means highly uh, high chance of erosion. Okay, that is why we use this C factor, that is why we calculate NDVI. Okay, but you can calculate any vegetation indexes, because there are very various vegetation indices are there, so you can calculate other vegetation indices also, but make sure that you have some let's say literature backing. Okay, to support your work. Okay, so in any step you want to try something different, so you have to rely on some work that is already being there. Okay, lab tested works. Okay, so so that one, so for that reason we use this crop management factor. Okay, we calculate NDVI, and then we rank from if this is vegetated or less vegetated area. Okay, and for this your F factor. Okay, the F factor basically what is that? What is the sorry, P factor? Where is the P factor? Okay, let's for example this is your P factor. Okay, so for the P factor, what is going to happen, that basically this is your conservation practices, if they have bounds or not, if the slope is there or not. Okay, so what are the other areas around there, those things. So basically crop management practices are there, and according to their crop management practices, they are basically give different numbers to that only. Okay, so for every work we have to basically calculate and prepare a layer, then we're gonna simple multiply it. Okay, I also share you the paper also, that where they uh, classify based on the weighted average. Okay, I also share you that also. I think this paper, I think. Okay, I will share you that. Okay, okay, so we have rainfall and LS. Okay, cover management and your P factor. Okay, so we have to do all our work using QGIS and Excel. Okay, but then in the after we already do for using the QGIS, I will also share you some Google Earth Engine or Python code to automate all your works. Okay, let's say you have to work let's say you have to work for other region, let's say for Western Ghat. Okay, so you don't have to go means prepare each and every data set for your area. Okay, you can directly use the code also. Okay, I will share you at the last when we completed one um, means one map. Okay, one soil erosion map. Okay, so then again we have to calculate each layer, and then each layer is basically given some values to it. Okay, and then we have to calculate our A. Okay, and then we have to classify. If this is less than 5, then this is in very low, and if this is greater than 40, this is in very high or severe category. Okay, you can, we have to uh, give the points there. Okay, very high or high or moderate or something. Okay, so where you can implement your work, okay, your soil erosion models, because for a research article, okay, what are the different things you can do? Okay, you can simply calculate a Russell model for a area. Okay, maybe for a administrative boundary or maybe a watershed boundary, or you can do a time series analysis also. Okay, previously what is going means from 2000 to 2026, how the soil erosion activity or soil erosion, soil loss is changed so through years, all those years. Okay, then also you can do predictive models. Okay, predictive models, uh, predictive models. Okay, so predictive models. Okay, so in the predictive models you can predict how in the future the soil erosion can change. Okay, this can lead to a high impact factor. Your research article can be published in the high research impact factor journal. Okay, rather than directly use this only the Russell model. Other thing what you can do, you can compare with your work. You can compare. Okay, compare with, let's say, some equations already there for your region. Okay, but there are other your other equations are also there, so you can compare to these two equations, how from these two equations your accuracy or your uh, means your data is varied. Okay, then you can compare with different models, use Russell model, muscle model, mmf model. Okay, and also main thing is that some machine learning model also there. Okay, you only download the data. Let's say for data, you can download temperature, rainfall, soil type, and your LULC data, and train the data to basically create some soil erosion model. Okay, a soil erosion map. Okay, then also you can compare with for example, like you can compare basic Russell model compared to your weighted average models. Okay, like ASP, if you have something in your mind to basically give different weightage, you can compare and publish a research paper that this is the change in numbers when we apply different methods. Okay. Okay, so this is can be some work. Also, you can use in some real world applications. Okay, like for example, a construction area. Okay, like for example, if you are if you are involved in um, uh, okay, let me first read some charts. Yes, after learning Russell in QGIS, you can easily write research article because in the Russell model basically is that the work is already there. Okay, the work is already there, the equations are already there, the maps are already there, you generate. So you can your, let's say, up to 7 to 8 pages are already filled. You have to only write the introduction, okay, and conclusion results according to your dataset. But your methodology is same, and there are various maps there. So this is very easy to publish in some articles. Okay, so here are some ideas. Okay, like you can compare with some machine learning model or some different type of equations. You can publish this one also. Also, let's say you are working for urban planning, and let's say you have to build a you have to prepare a plan for urban development or some construction sites. Okay, so you can predict that this much of soil in the if there is high rainfall chance, then you can predict that, let's say, this much of rainfall if happens, this much of soil erosion can initiate, and this can lead to hazardous effect for your construction site. Okay, so this is also can be a work, and you can pitch this project idea to the construction site. Because if let's say there is you build a construction site, and there is, if the rainfall is very high for this year, then the soil erosion is very much there. So it can deposit here, and it can let's say do some problems here. Okay, also you can compare the dams also. Okay, let me show you how these papers are. uh, See, okay, see what is this paper. This paper is basically GeoAI based soil erosion risk assessment using Russell and advanced machine learning model. So it published in Environment Monitor Access, okay, in this journal. And if you see this journal, okay, see, this is 3 imperfected journal. Okay, this is 3.2 5-year journal. This is 3.2 imperfected journal. Okay, so this is 3 imperfected journal, and what he did in this paper. For the Brahmaputra basin, the Russell model work is already there. Okay, so they created this data for different years. Okay, but also they also compare with machine learning models. Okay, see, okay. Okay, see, uh, here they have accuracy here, like let's say Russell model. Also, he used this random forest, and what is this bias? Okay, gradient boosting. Okay, so but here only gradient boosting and random forest is model is there. So you can generate for your area, you can include some ANN models. Okay, also some other tree models. Okay, decision tree models are also there. Various decision tree models are also there. I'm forgetting the names. Okay, so you can integrate and you can classify for this area also. Okay, because you are using different data set or different models. Okay, okay. Also, see, this is very common work. Okay, there are various papers are there for this work. Soil erosion and sediment yield modeling. So basically, they compare the soil erosion loss data with your sediment yield modeling data. Okay, so again this sediment yield modeling, again the same, some equations are there, you have to calculate and you have to just compare these two. Okay, and this is also a good journal, total environment research. Okay, also okay, if- see again sediment yield model. Okay, Okay, see here, what is the did here that, see, soil erosion trend, and then future prediction also. Okay, in this spine. Okay, and this is international soil water conservation. So this is highly high impact hydrogen. Okay, and see here, first he calculate all the sediment data. Okay, so erosion data, and then this, he used this CMIP6 data. Okay, also this MIROC6 data, and it can predict the future climate, and you can integrate the data into your model to calculate what is it happening in let's say 2050. Okay, 2035, you can easily predict. Okay, the work is almost same. Okay, also here I have a work which you see, this is simple only, relation between drought and soil erosion. Okay, you can compare with NDVI, you can compare with LST. Okay, it's a land surface temperature, calculate land surface temperature with soil erosion, and you can see that how the this means how this land surface temperature is linked to your soil erosion loss. Okay, okay, see, this is a dam project. Okay, dam. Okay, so here he used the soil erosion. Okay, so we basically put the see, he put the outlet point here, and it can create the your basin, or your catchment, and for that catchment region you calculate the soil erosion loss, and you can say that this much of soil is accumulating per year in this dam. Okay, so this type of works you can easily do, and after the completing the after completing this course itself. Okay, okay, so you can calculate this water quality also, because using some using various satellite data set, you can directly calculate the water quality, the turbidity. Okay, you can calculate turbidity. Okay, your your TDS and TSS you can calculate using remote sensing, and then you can compare the sediment data, so soil erosion data to the this one. Okay, see the urban, okay, to forestry, or let's say some biodiversity areas, climate change. You already seen that how climate change is the paper are also they there. So these all works can be done using this Russell model, and you can uh, incorporate into your works. Okay, so basically for the first day I thought of only to um, show you that what are the possibility of this soil erosion data. Okay, okay, if you know the data set, what are the possible works you can do, what are the possible risk articles you can prepare. Okay, so I thought only for this agenda, for today, the agenda only to know that the potential of this work. Okay, so if you have any doubt, you can ask. Yes, Subham, PPTs also share. I'll share you the PPTs and the research articles too.
Sir, how we will be getting these PPT and materials? Do we have any group or
Yeah, by
something?
your mail, you have
Okay, shall we
your
share
mail
the
is
mail
there.
here?
Uh, uh, when you are registering for this course,
Okay.
you already
Okay.
give your mail, na?
Okay, okay.
Or share so in the chat. Nagendra sir, share the number. You can share your detail there also.
Hello, sir.
Yes, yes. Abhijit.
Sir, what is watershed? Is it flow direction of drainage pattern or drainage flow and the catchment where water may be accumulate, is it the same or is it is something else?
No, that is same only. The catchment or the watershed is basically a boundary where two areas are being distinguished. When this, let's say this one is a watershed boundary or a catchment boundary. That means every raindrop that is falling in this area can be accumulated at this point. Okay, so this is a drainage divide basically.
Okay,
So
so
this is
this
your
is
watershed.
basically same as the catchment itself, right?
Yeah, yeah.
Oh,
Catchment basically, the catchment is applicable for larger areas and
mm-hmm.
watershed for smaller areas.
Okay,
And basin also for one river, you can for larger river, you can use the term basin, and for the subsidiary, you can use the term sub basin. That's all.
okay, okay, got it, sir. Thank you.
Okay, so if uh, you have any question or left? Okay, so from next day, please prepare for some hectic works. Okay, I will demonstrate some works. I will share the data set, and simultaneously you have to prepare your prepare or follow the steps. Okay, so please prepare for that, because after that, if you think that let me see the all the um, let's say all the level.
Nihar, please stop the recording.
Okay. Okay, sir. Let me first only show you the QGS, then only then I can stop. Okay. So anyone worked this QGS? Anyone know all uh, all participants are already know about the QGS, or anyone is showing let's say QGS for the first time?
We know, sir.
Okay. Okay. Okay, so for the works from the data set, please prepare a folder. Okay, prepare a folder where you have to save all your outputs and inputs. Okay, so first thing you have to okay, basically mine is here yellow, but yours maybe white. So let me. Okay, here we have then. Okay, then you have QJS. Okay, then here you have some plugins. Please check the toolbars required. Okay, your panels must be ready. Okay, this your layer styling. Okay, okay, layer styling panel must be active. Okay, then you have to create a folder where you can save all your data set, so the data are not cluttered everywhere. Okay, then you have all are requested to install. Okay. Okay, so please install not all this. Okay, okay, I'll show you in this what are the. Okay, so here you have to download your this quick OSM. Okay, quick map. Okay, this quick map services. Okay, please install this quick map service plugin. Okay, Also the SCMGIS plugin, okay, for base maps. Then for your this calculation, your this semi-automatic classification plugin, okay, this SCP plugin, you have to install this plugin also, okay. Okay. Also, I will share you that you have to go to their site, like for let's say you have to download, let's say you have downloading SRTM data. So you have to go to this Earth Data plugin, Earth Data website, and then you have to log in, and then you have to download the data. But here also you can download your data. Let's say there is a plugin known as the DEM downloader. Okay. So DEM. Okay. Okay. So for next day, you only just download these three plugin. Okay, SCMGIS, then this quick map services, then this semi-automatic classification plugin. Everyone know how to install this plugin, or anyone don't know?
So I have one query.
Yes, please.
Actually, sir, I am using currently I am using MacBook and Mac operating system. So this semi-automatic plugin doesn't get installed in my system. Like every time I have tried it and it doesn't get installed. So that is one problem with it.
Okay, so go to your browser and okay, 1 minute. Okay, I will show. I will say share you the this. Okay, so from here, please download the plugin itself. Okay, the zip folder is downloaded. Okay, and after the download, you go here from install zip file, and then upload here, and you can install plugin also here. SC plugin.
Okay, sir.
I will share you that file, the SV plugin,
Okay.
that zip file. You only have to go to this install from zip, then go here, then you can directly select that folder and then click here install plugin.
Okay,
Okay.
sir. Okay. Sir, one more thing. We are doing this manually in QGIS or through PyQGIS coding?
No, yeah, for this course we are using this manually.
Manually. Okay.
Okay. I'll share you show you both unsupervised and supervised classification. Okay. The Pallavi Singh, yeah, using it for first time. So for that you have to download QGIS from here. Here, go to this QGIS. Okay, search for QGIS. Okay, then download your QGIS file. Okay, no, sorry, here. Okay, download your QGIS and then install it. For now, QGIS 4 also available. Okay, so just go here and download the. Okay, see. Okay, see, download from directly from here. Okay, then we will proceed from. Okay, please, if I think okay, see, if you are downloading for the first time, please do not download this for the QGIS 4 for now, because there are various plugins are not supported in QGIS 4. Okay, so it is safe for better, let's say, to follow the steps. So please download this 3.44 version. Okay, download it, then install it, then we'll see all the steps from tomorrow. I will share you the data set because the internet connection is not good for everyone. So I'll share you the data. Also, I will share you where to download the data, how to download it, and also I will share you the data set also.
Okay, sir.
Okay, so we will be okay. So let me pause the recording.